Lesson 2.4 is about special pairs of angles. Okay, the first special pair of angles are two complementary angles. And two complementary angles are any two angles that add up to 90 degrees. They don't have to be in the same figure, but they add up to 90 degrees. So on the left here, if this is, suppose this is this whole thing is a 90-degree angle, then if I make one part of this, whatever this is, x, then the other part will be the other piece of the 90 degrees, or 90 minus x. Okay, so for example, if the little angle on the bottom is 20, then the big angle up on top will be 70. Their sum will always be 90 degrees. Those two angles are complementary. In a right triangle, if I have one of the angles as a right angle, that takes up 90 degrees of the total 180 degrees inside of a triangle. So the other two, these two acute angles, will always add up to 90 degrees. So as an example, if one of these is, say, let's say one of them is 60 degrees, then the other one will be 30 degrees. It's not drawn to scale, but those two would always add up to 90. And then, you know, again, the angles don't have to be connected in any way. It's just that the combination of the two has to add to 90 degrees. So maybe I have a 45-degree angle here and another 45-degree angle across the page over here. Together, these two angles, because they add up to 90 degrees, are considered complements to each other, or complementary angles. Next we have supplementary angles, and two supplementary angles, again we're only talking about angle pairs, not groups of 3 or 4 angles, but any two angles that add up to 180 degrees are supplementary. So of course any two angles lying along a straight line, which you remember we call a linear pair. A linear pair of angles always have a sum of 180 degrees. So we know that this whole big angle along here is 180 degrees. So if one of these angles is x degrees, then the other one is 180 minus x degrees. So for example, if the little angle on the left was 20 degrees, then the big angle on the right would be the other 160 degrees of the 180. And again, the supplementary angles do not have to be adjacent to each other or near each other to be supplementary. So I can have any two angles, like say if this angle is, well, let's make this one 80 degrees here, and if this one is 100 degrees, then together these two angles are supplementary. They are supplements to each other. Okay, and then lastly we have vertical angles. Whenever you have two intersecting lines, you form vertical angles, and they are across from each other. So as an example, with these two cross lines, angle 1 and 3 are vertical angles to each other. They're formed by opposite rays on the intersections. And angle in this diagram, angle 2 and 4 are vertical angles to each other. They are a pair of vertical angles. And the big news is that vertical angles are congruent to each other. So in this case, the measure of angle 1 is equal to the measure of angle 3. And then whatever the measure of angle 2 is going to be equal to or congruent to the measure of angle 4. So that's vertical angles, and vertical angles are always congruent. I think of this theorem like scissors, like when you spread, you know that when you spread the handles of scissors wide, that the actual scissor blades themselves are at the same angle as that you're holding the handles at. And so I think that vertical angle theorem is fairly intuitive to us all. So anyway, we'll be using it a lot, and that's it.